Hi everyone. So I want to talk to you today about the loss of trees, and particularly hollow-bearing trees, in both prescribed burns and bushfires, and most importantly about how we can minimise those losses. I'm guessing in this audience I don't need to highlight the importance of hollow-bearing trees to our native fauna, but just some interesting figures for you. 15% of our native wildlife use hollows, 15% of species that is, and when you're looking just at mammals, that's 31% of mammal species. And often an individual within a species will use multiple hollows, so an individual might use 15 different hollows. And for species that require very large hollows, like thinking black cockatoos and brush-tailed possums, it's been found that those hollows take over 200 years to develop. So you can see how the loss of a tree of that age is very significant, and that tree is not going to be replaced, certainly within our lifetime. Now, fire is a natural process, and it's a very important process in the development of tree hollows. So hollows usually form when a branch falls off or a tree gets damaged, and either fire or fire, fungi, termites and things will gradually eke away at that dead wood and create that hollow. So fire is a very important part of hollow formation. Fire also causes trees to collapse as those particularly hollow-bearing trees burn out. And in a natural system where you've got a fully vegetated landscape, the rate of hollow formation would be approximately equivalent to the rate of hollow loss. Unfortunately, as we're all very well aware, we no longer have a natural environment. Our environment looks much more like this, where we've got areas that are very cleared, and even in those habitat patches that remained, they're very heavily modified. So suddenly that formation and loss of hollows, that balance isn't working, and so we've got a scarcity of hollows within the landscape. Within those modified patches, lots of those patches have been logged, and logging's been found to result in the loss of between 50 and 90% of hollow-bearing trees in logged patches. And I was shocked for the figure that 82% of our eucalypt forests in Australia have been logged, and that figure was only accurate as of 1992, so I hate to think what it is now. And that results in situations like this where you get very large numbers of very small trees and very, very few large trees that are hollow-bearing left. When we're talking land clearance for agriculture or for urban areas, like this, you've got the losses of hollow-bearing trees from those landscapes is more like 80 to 90%. And then you've just got these, really quite iconic trees, single trees left as paddock trees within a landscape or along roadsides. So you can see in this sort of system, now the loss of these hollow-bearing trees during a fire is much more significant, and we need to minimise the losses of these trees. So what's known about tree collapse rates? Well, up until recently, there were only really 2 papers that talked about tree collapses in prescribed burns, and they estimated collapse rates between 14 and 38%. But as you'd appreciate, 38% of hollow-bearing trees is pretty significant. Very recently, as of last week, a report was published by Lucas Bluff in Victoria, working for the Department of Environment, Land and Water and Planning. And Lucas has been doing a really large-scale study, which is very exciting, to try and quantify the loss of hollow-bearing trees in prescribed burns. This is a bit of a complicated figure. You really only need to concentrate on this pie graph here. This pie graph here represents of all of the trees that they had at different sites that were subject to prescribed burns. Those are the trees that fire actually reached the base of those trees. Of those, about 25% of them collapsed and about 25% were damaged in some way. So again, pretty significant figures. Now, one of the things that Lucas was doing at the same time was measuring the various attributes of the trees to work out which trees are more susceptible to collapse. And the findings of his really very much echo what we've been seeing during our prescribed burns, that trees are more likely to collapse if they are dead If they have a hollow base, and the larger the size of that hollow in the base, the greater the risk. If they are hollow bearing, and the larger the hollow, the greater the risk. And also then, separately from the tree attributes, trees are more likely to collapse as fire intensity increases. That's important to keep in mind because obviously bushfires that occur at a much higher intensity typically than prescribed burns. Now, at the same time, or prior to us realising that that Lucas was doing this work, we were recognising that we were having hollow-bearing tree collapses within our prescribed burns, and we wanted to work out what we could do about that and if we could reduce those collapse rates. So what we did is we established a monitoring program, and we identified vulnerable trees at 6 prescribed burn sites prior to those sites being burnt. This is Vic here mapping those hollow-bearing trees using a grid system, and this is actually a practice that we now do routinely for almost all of our burns in association with our pre-burn weed mapping. So at those sites prior to the burn, we marked and photographed the vulnerable trees and then measured a variety of attributes like the proportion of dead branches, the size of hollows, whether or not they had a hollow base, etc. And also the fuel levels surrounding them. Sorry, Naomi. We then randomly assigned each tree to either a fuel treatment, and that was essentially the crew going out and raking around and removing all the vegetation from within at least a metre of the tree base. So that was either using rake hose and or brush cutters, depending on the type of that vegetation. And then we had our controls trees where we didn't do any of this fuel. You'll notice when I get to the data that although I say we randomly assigned them, this is where kind of management overrides the science a bit. And there were a number of sites that we got to, and the trees that we were talking about were so significant in this landscape because they were so scarce that I just couldn't bring myself to not treat them. So hence there are far more treated trees than untreated trees. Following the burn, we re-photographed the trees and used those photographs to assess the percentage impact. And we also measured the burn intensity surrounding that individual tree. So you can see here, this tree here, fairly minimally impacted, although it's this dead wood here that has a number of quite big hollows in it that has been burnt out. This tree here has what we'd be deemed as complete collapse. And it's not that clear, but you can see that dark patch there is a hollow at the base of the tree, and there's another hollow there. Those hollows were probably connected internally. The fire has got in there and chimneyed out and caused the collapse of that tree. So if we look at some results, can we reduce the collapse rates? It looks like yes, we can. See how bad these numbers are? But anyway. We've got the percentage of trees that we monitored here and the degree of impact from pretty much no impact through to complete collapse of a tree. And so these are the trees that we didn't remove fuels from around the base of, and these are the ones that we did. So about 20% of trees were collapsing that weren't treated, and 7 to 8% of the ones that we did. So it's great to see that reduction. It's worth noting that those percentages can't be compared with those first two papers I talked about, the 14 to 38% collapse rates, because those collapse rates were a proportion of all hollow-bearing trees within that landscape. This is just the proportion of those trees that we deem to be the most vulnerable. So if you took that as a proportion of all hollow-bearing trees, those percentages would be much less. Probably the reason for some of that is the burns we're talking about are relatively small, and our firefighters, although we say these are not treated trees, our firefighters are very well versed in protecting hollow-bearing trees, and if they see a tree catch alight, they will extinguish it. So some of those trees might have received a different level of treatment. Like the Victorian study, we found a relationship between the percentage the tree is impacted and essentially this is the measure of fire intensity. It's a pretty weak relationship, but it's still there. What you will note though is even at relatively low fuel intensities, even where we've removed fuel from around trees, you can get cases of complete collapse. Most of these trees are stringy bark trees, and really it only takes an ember to land on that bark or in a hollow where you've got, a nice build-up of dry leaf material and small twigs and things, and once that gets burning, you're going to expect a level of damage. So management application, for those of you involved in fire management, these are the things that we've found overall reduce our collapse rates. Firstly is that removing fuels from around the base, excluding patches of significant trees. Often we find that they are in clumps, possibly as a result of areas that haven't been logged. Reducing the fire intensity, that can be done across the entire burn site, although that might compromise other ecological objectives. And so what we do now is often our firelighters will light up immediately around the base of a significant tree. That causes a low intensity backing fire away from that tree, and that works really well. And our crews are very good at wetting down trees that might be close to them before they catch fire, or extinguishing any that do. Important to note that we can't completely eliminate tree collapse, and that a level of damage, I guess, from fire and things is important in that hollow development. Also important to remember that bushfires are going to create presumably much higher rates of collapse, and that one of the benefits of prescribed burns is that if you then get a bushfire through that area, it's going to burn at a lower intensity, so hopefully some of those hollow bearing trees are less likely to collapse in a bushfire situation. So I now want to talk about bushfire, and there are a few slightly different issues with bushfire. So we have this tree collapse when the big old trees burn out, but we also have trees that are felled, and they are felled because they are considered to be at risk to, considered to be a risk to people and property because they've been structurally undermined by the fire. But presumably many of you will have noticed that following the Samson Flat Fire, there seemed to be a very large number of trees that were felled that didn't appear to be that hazardous. And lots of even the very big trees seem to be, really solid through them. So this caused a lot of concern for a lot of people, and it's something we started looking into. I don't have any data on this, but based on all the conversations we've had, we've looked at kind of why trees are being felled and what we can do to reduce the loss of trees following bushfire. So firstly, and importantly, trees are removed after bushfires because some trees do present a very real safety risk, whether it's to firefighters, whether it's to people, property owners returning to their properties, or people travelling along those roads. So that is very important that that is done. But we've also acknowledged that there seems to be a lack of a process during bushfire events in terms of how you go about assessing burnt trees. You can imagine in a bushfire situation, it's a pretty frenetic situation. The incident management team has to recruit lots of arborists who have obviously different levels of skill. They've got to recruit tree felling crews. All of those people work in slightly different ways, have slightly different expectations as to what they need to do and what they consider to be a risk. And very quickly you can see how there can be a few gaps and trees might get cut down that weren't intended to be or shouldn't have been cut down. There's also, though, within the broader community, some misconceptions. So landholders were cutting down trees, and there seems to be a perceived risk that all burnt trees are hazardous. And I wonder, in part, if this is a bit of a misinterpretation of some of the media messages that come out during a fire. You've got landholders that are desperate to return to their properties, and the message they're getting is, we know you're desperate to return, but you can't until we've removed the hazardous trees, which may be interpreted as burnt trees are hazardous trees, and so when people go back to their properties, they want to remove those hazards. There's also a perception that trees are a major contributor to bushfire risk, and this isn't actually the case. So the spread of bushfire occurs due to the fire moving through those fine fuels, so the leaf litter, the small shrubs and things in the understory. There's a perception that all burnt trees are dead, just that lack of understanding that our native eucalypt species regenerate through respouting after fire. And also then that dead trees have no value, and we also know that dead trees are very important to many of our native fauna species. There also seemed to be a fair bit of opportunistic removal, maybe people who thought, I always wanted that tree to go and I was never legally allowed to do it, but hey, there's a fire and it's a risk, isn't it? And things like that. And people actually following arborists around and copying their marks on trees, and the tree felling crews then coming through later. And so that sort of thing. So our challenge is to develop a really good risk assessment process for burnt trees so that we can confidently assess which trees are actually hazardous and only remove those. I think the responsibility of this people in this room more broadly is to increase awareness about the value of hollow-bearing trees and their post-fire response, so people think twice before they're going to cut down a tree on their property. And also increase understanding about fuel management, so they know what they really effectively need to do to reduce the bushfire risk on their property, and they don't remove things that they don't actually need to. Thank you.